Hello and welcome to Monochemistry. Today we're going to look at the standard enthalpy of reaction. So in class today we looked a little bit at the standard enthalpy of formation and the standard enthalpy of combustion. And those have very set values. The standard enthalpy of reaction, on the other hand, doesn't necessarily have a set value because it's not necessarily something went into the lab and has calculated over and over again to have a set value. So there's a couple of different reasons we use this. First of all, to calculate, what the standard enthalpy of a reaction would be, but also to be able to compare it to results that we get from the lab. Okay, so this one is no particular type of reaction. It can be any reaction. It doesn't matter if it's combustion or formation or whatever. It allows us to calculate the change in energy of a particular reaction. Okay, so again, delta H of reaction is going to be measured in kilojoules. Now, just let me talk about this equation here so that we're clear. So this equation here is the one you're going to use. Now, let's just go through it. So this is the delta H standard of reaction. So the standard enthalpy of reaction is going to be equal to sigma. Okay, so that's a sigma. Don't mind my writing. I'm sure you guys have used sigma before, but it means the sum of the delta H of formation of the products. Okay, so the standard enthalpy of formation of the products minus the sum of the standard enthalpy of formation of the reactants. Okay, and that's the equation that we're going to use. Make sure you write that down and make sure you know what each of those represents and that you understand what they are. If you don't, make sure you write down a question that you have so you can bring it to me in class. So the best way to look at this really is to do a practice problem, and the one we're going to look at here is one we actually looked at in class. Believe it or not, this reaction right here that you see is a formation equation. Okay, so we already know what the value for this should be. But I'm going to show you how you can use the delta H of reaction to calculate that same value that you already have in the chart here. Okay, so there's water, liquid water. All right, so what is the delta H of this reaction? Okay, so this is the delta H of reaction, which happens to be equal to the delta H of formation. But we're going to use the new method to figure that out. Very quickly, and you should write this down, this is very important, when dealing with enthalpy of reactions, standard enthalpy of reactions, an element at room temperature, the delta H of formation of an element, write this down, the delta H of formation of an element, whether it's regular or diatomic, is always going to be equal to 0 kilojoules. Always going to be equal to 0 kilojoules. Okay, that's the delta H, standard delta H of formation of an element. Copper, sodium, copper, doesn't matter. 0 every single time. Okay? So when putting in the values for these, notice that they're not in here. There are no elements on this chart. When putting in the value for these, you make sure that you put in 0. Okay? So the only delta H of formation that we really need to know in this case is the one for liquid water, which in this chart is negative 285.8 kilojoules per mole. Okay? All right, let's move on. Okay, so here's the setup that we're going to use for this question. Remember, we're doing the delta H of reaction for the formation of water. So we have our equation. Okay, now what I'm going to do is I'm going to show you how to put in the equation. Okay, this is very important. And then I'm going to give you a problem to try on your own. Okay, see if you can do it yourself. All right, so it's the sum of the delta H of the products. What's the product in this case? Is there more than one or is there only one? Well, in this case, there's only one product, and that is water. And the delta H of formation of water, according to this chart down here, is negative 285.8. So I'm quite literally going to write that in right here. Negative 285.8. Okay, my final answer is going to be in kilojoules, so it's not necessary to write anything besides that. Now, if there was more than one product, I would add up all the values for each of those products. There's only one product, so I'm only going to put that one thing. So there's not really much of a sum in this question, but in some questions there will be 4 or 5, maybe, that you have to add together. not in this one. Okay, now here's the thing. There was only 1 mole of water in this question. Okay, so I implied that there's a 1 there. If there's a 2 or a 0.5 or a 3 or a 17, you have to multiply that through. So if there's 17 moles of water, then I would have to put a 17 in front of it. If there's 0.5 of a mole of something, then I have to put 0.5. You have to take in the number of moles of each thing when you do this equation. That's very important. So I'll show you how to do that over here. Okay, so I already told you. We did hydrogen plus oxygen. I already told you that those are 0. Okay, so my reactants, hydrogen plus oxygen, well, it's going to be 1 times 0 plus 1/2 times 0. Okay, just for emphasis here, we knew that there was 1 mole of hydrogen and half a mole of oxygen, so I'm just going to make sure. So it's very important that you go ahead and put that in. Okay, so now all I have to do to get my final answer is add it up. So my delta H standard of reaction is going to be equal to, if I sum this all up, this is negative 285.8 and this is 0. So the final answer is going to be negative 285.8. Okay, so I want you to do the same thing. I want you to do the exact same question, but I want you, instead of using water, I want you to calculate the delta H of reaction for the formation of, let's say, carbon monoxide. Okay? I want you to do the standard delta H of reaction. You can bring it to class tomorrow and I'll check to make sure you can do it. This is the basis. We'll do some harder ones tomorrow in class, but I just wanted to give you the gist of it. Okay? So make sure you go back and take notes. Keys to this, why we use it, when we use it, when we're calculating delta H of reaction, but also don't forget, elements have a delta H of formation always of 0. Don't forget that. That in a nutshell is how we calculate and use the standard enthalpy of reaction.